Nirmala Reddam. In this video, I am going to explain exercise 3.2 from NCERT textbook class 8. So here, in this exercise, we are going to discuss the exterior angles of a polygon. Okay, so what do we mean by exterior angle? If you take a triangle for an example, right? Triangle is a polygon of 3 sides. Okay. Now let me name the triangle ABC. If you were to extend the sides of the triangle in any direction, but you need to maintain the consistency. Here I am extending in anti-clockwise direction. Okay. Now the angles made by this extended side with the adjacent side are nothing but the exterior angles. So if I name them 1, 2, 3, exterior angle corresponding to vertex C is 1, exterior angle corresponding to vertex A is 2, exterior angle corresponding to vertex B is 3. Okay. Now here, if I were to change the direction, that is if I extend the sides, if this is the same triangle ABC, if I extend the sides in the clockwise direction, okay, what will happen? Right? So here, extended side with the adjacent side, extended with the adjacent. These are the exterior angles, right? Now take vertex A for example. Here you will see that this angle is the same as this. Why? Because if you can recall, these two are nothing but vertically opposite angles. So which are of equal measure. So you can extend the sides in any direction, clockwise or anti-clockwise, but you need to maintain the consistency throughout the polygon, right? So these are the exterior angles of a given polygon. Now here, what we are doing is, we will be doing an activity to check what is the sum of the exterior angles of any given polygon. Okay. So the activity is, they want you to draw a pentagon on the floor with the chalk and walk along the pentagon and see if you will end up facing the same side that you started with, same direction that you started with after you complete covering the polygon. That is, you have walked along the polygon once. Okay. So in order to do this activity, I will show you a quick time-lapse video of constructing this pentagon. As you can see, I have not taken any specific measurements. We just want a pentagon which is a polygon of 5 sides. Okay. Right, so now we have our pentagon ready. Okay, and I'm going to take this small Lego block model of this chap here. Okay, he's going to start from point A. Right, he's going to start from point A. Now, in order to fix the direction or to be sure of the direction, I have a model of his home here. Okay, this is his home, and initially we are going to say that he is facing his home, right? Clearly he is facing his home. Now let him walk along the pentagon. He walks along AB, right? Once he reaches B, he is going to turn by an angle 1, right? And walk along BC and then turn by angle 2, okay? And then walk along CD and turn by angle 3. Walk along DE, turn by angle 4, and walk along AB and then turn by angle 5. So now you know that he has turned by angle 1 plus 2 plus 3 plus 4 plus 5, which is the sum of the exterior angles of this polygon, right? Also, if you have noticed, he has not been able to face his home through the entire journey, right? Until he finished the entire journey. That means that once he finished the journey, he is again able to face his home. That means he has made one complete turn. and you know that one complete turn or one complete rotation is nothing but 360 degrees. That means that the sum of the exterior angles of a polygon is equal to 360 degrees, and this is true for any polygon, not just a pentagon. You can actually try with other polygons as well, and I do suggest strongly that you do this activity, because the result that you get is very important. The result that you get out of it is very important, and you will be using it very frequently in geometry, and this way, by doing the activity, you will never forget it, right? That okay, I go along the polygon, how many ever sides the polygon has, and you would have made only one rotation, not less than that, not more than that. Okay, so here, that is the result that he's got. Sum of the measures of the external angles of any polygon is 360 degrees. Okay, right. Now, let's look at the example here. Find the measure x in this figure. Now, they have given us we have a quadrilateral. That is, this is a polygon of 4 sides, right? Now, here, they have given us 3 of these sides, right? Just now we have looked at the result that sum of the measures of all the exterior angles of any polygon is 360 degrees. That means that if I were to add all these 4 angles, that is x plus the remaining 3 given as 90 and 50 and 110, this is equal to 360 degrees, right? That is the result that we just looked at. And from that calculation you will get that the measure of the fourth exterior angle is 110 degrees. Okay, so that is your solved example. And then you have, if you were to take a regular hexagon, now they are mentioning that it is a regular hexagon. That means that this hexagon, which is a polygon of 6 sides, has all the interior angles equiangular, that is all the interior angles are same. Here he has taken it as measure A, and all the sides are equal. Okay, all the 6 sides are of equal length. Now the question is, what is the sum of the measures of its exterior angles? Now we have looked at the result, right? Sum of the exterior angles of any polygon is equal to 360 degrees. So the answer here is 360 degrees. Sum of the measure is 360 degrees. Is x equal to y equal to z equal to p equal to q equal to r? That is, are the exterior angles of the same measure? If they are, then why? Now, how do we solve this? Now here, we know that the sum is 360 degrees, but they need not necessarily be equal. But because this is a regular hexagon, you know that each of these is A. Now if you look at this, for example, what is this A plus x? A plus x nothing but forms a straight angle, because see, you have extended this side in order to get this exterior angle. That means this is a straight line. That means this angle is a straight angle, which is nothing but 180 degrees, right? That means that x is nothing but 180 minus A, right? Clearly, you can say that y is 180 minus A, z is also 180 minus A, p, so on so forth, right? So you clearly see that these exterior angles are also equal, right? So for a regular polygon, you can conclude that for any regular polygon, equiangular means interior angles are equal, from which you can conclude that exterior angles are also equal for any regular polygon. Okay. Now why? We have just looked at the reason. So this is done. Next, what is the measure of each exterior angle and each interior angle? Now how do you solve this? How do you find out the measure of each exterior angle? Now let one of them, for example, let x is equal to E. I'll call it E. Because all the exterior angles are same, I can say that y is also equal to E, z is also equal to E, and so on, right? And I already know the result. Sum of the exterior angles is 360 degrees, implies I have 6e, because I have 6 angles here, is equal to 360 degrees. From this I can conclude that each exterior angle is of measure 60 degrees. Okay, so that is the answer. The measure of each exterior angle is 60 degrees, and from this I can conclude that measure of each interior angle is 120 degrees. Why? Because these two, interior plus exterior, for any polygon, not just regular, interior plus exterior forms a straight angle 180 degrees. Okay, so if exterior is 60 degrees, interior will be 120 degrees. Okay, so that is the third question. Next, repeat this activity for the cases of regular octagon and a regular 20gon. Okay, let's look at a regular octagon. So here I have a regular octagon, right? Regular octagon has 8 sides. Okay, regular octagon means n is equal to 8. Now here, like I told you, because they are saying regular, okay, whenever you are talking about a regular polygon, NE is equal to 360 degrees, because each exterior angle will have the same measure, and sum of the exterior angle is sum of n e's, which is n into e. Okay, so n times e is equal to 360 degrees, implies each exterior angle is equal to 360 divided by 8, which is nothing but 45 degrees, right? So this is the measure of the exterior angle of a regular octagon. Now here, next question that they have asked is interior, right? Now what is the interior angle? If exterior is 45 degrees, I know that interior plus exterior is equal to 180 degrees, implies interior angle measure is equal to 180 minus 45, which is nothing but 135 degrees. This is the measure of the interior angle, right? So next is a regular 20gon. So if I take n is equal to 20, it becomes a 20gon, right? So now here I have n into e is equal to 360 degrees, implies e is equal to 360 by 20, which is equal to 18 degrees. Okay, now if n is equal to 18 degrees, I have I plus e is equal to 180, straight angle, implies I is equal to 180 minus 18, which is equal to 162 degrees, right? So that is my interior angle of a regular 20gon. Now here, please remember that the formulae or the result that we are using, that n into e is equal to 360, is true for regular polygons. Okay, the general result for any polygon is sum of the exterior angles. Okay, sum of the exterior angles, whatever be the measure of this angle, they will be different, same, whatever, the sum is going to be 360 degrees. That is my result for any polygon. But in case of regular polygons, it so happens that all the exterior angles are of same measure, therefore n into e is equal to 360. Okay. Now the next result that we use, that interior plus exterior is 180 degrees, is true, again true for any polygon, because this is nothing but a straight angle. You are extending the side to get the exterior angle, therefore it has to be 180 degrees. Okay, by definition of exterior angle, this is true for any polygon. Okay. Now the next question is, find the number of sides of a regular polygon. They want us to find n whose each exterior angle has a measure of 45. E is given as 45 degrees. Okay. Now how do you solve this? N is what I need to find out, right? and what they have given us is exterior angle measure. Exterior angle E is equal to 45 degrees. Now because they are saying it is a regular polygon, I can write N into E is equal to 360 degrees. Implies N is equal to 360 by 45. Okay. Now if you simplify this, you are going to get 8. That means that the polygon is a regular, nothing but a regular octagon. Okay. So that is your second solved example. Next in the exercise, the first question is find x in the following figures. So here you want to find x. We know the result, sum of the exterior angles of a polygon is 360 degrees. So for the first sum you have x plus 125 plus 125. This is nothing but sum of the exterior angles is equal to 360 degrees, implies x plus 250 is equal to 360 degrees, implies x is equal to 360 minus 250, which is nothing but 110 degrees. Okay, so x is equal to 10 degrees, 110 degrees. That is the A bit. Next here you have regular, no, sorry, not a regular, it is a pentagon, right? And they want us to find this x here. Now I have these two angles. What about this angle? Do I know this angle? See, this symbol here means it is a right angle, right? It is a right angle or 90 degrees. If this is 90 degrees, we already know I plus E is equal to 180. That means that if this is 90, this is also going to be 90, right? So this is 90 degrees. Similarly here they have given the symbol this, that means it is a right angle or 90 degrees. So now quickly let us write down sum of the exterior angles. X plus 90 plus 60 plus 90 plus 70. Now this sum is equal to 360 degrees, implies. Now what is this? 90 plus 60, 150 plus 90, 240 plus 70 is 310, right? So x plus 310 is equal to 360, implies x is equal to 360 minus 310, which is 50 degrees. So this is your answer for the B bit. The unknown exterior angle is 50 degrees. Now next question, find the measure of each exterior angle of a regular polygon. Now here we have come to regular polygon, so we will be using the result N into E is equal to 360 degrees. Okay, so let us do this sum. Let's take a new page. Okay, so this is my second sum. Okay, I have n is equal to 9. For the first bit, n is given as 9 and they are saying that it is a regular polygon, right? That means that n into E is equal to 360 degrees, where E is each exterior angle, implies E is equal to 360 by 9, which is nothing but 40 degrees. Okay, so that is your answer for the first bit. Second bit is n is equal to 15 degrees. 15, n is equal to 15, so the number of sides is 15. So n into E is equal to 360 degrees, implies each exterior angle is equal to 360 divided by 15, which is nothing but 24 degrees. So each exterior angle is of measure 24. Okay. Next question. How many sides? So let's read the question. How many sides does a regular polygon have if the measure of an exterior angle is 24? We actually just solved this here because n into e is 360. If n is 15, e is 24. If e is 24, n has to be 15. Okay. So the answer here is 15 because n into e is 360 degrees. Okay. So the answer for this is n is equal to 15 because 15 into 24 is 360. Okay. Next question. How many sides does a regular polygon have if each of its interior angles is 165? Now how do we solve this? Let us look at this. They're saying that it is a regular polygon and interior angle measure is 165. Okay. So third is done. Fourth one, interior angle is given as 165 degrees. Now because it's a regular polygon, I know that n into e is equal to 360 degrees. Okay. But in order to use this result, I need the exterior angle measure. Okay. And then I'll find out number of sides. Now, is there anything relating this interior angle and exterior angle? Yes, we have seen sum of interior and exterior angle for any polygon is 180 degrees. Therefore, exterior angle is equal to 180 minus 165, which is nothing but 15 degrees. Right? So, now I can say that n into 15 is equal to 360. Again, I have the same combination 360 by 15, which will give me 24. So this polygon has 24 sides to it. Okay. This polygon has 24 sides. That is your fourth question. Next, fifth question. Is it possible to have a regular polygon with a measure of each exterior angle 22? Let us check that. So he is saying that is it possible that the exterior angle is 22 degrees and it is a regular polygon? If it is a regular polygon, n into e has to be equal to 360 degrees, where e is the each exterior angle, n is the number of sides of that regular polygon. So n is nothing but, for this case, divided by 22. So in 2 table, if you cancel, you will get 11. 2 ones 180. Now here clearly you can see that this is not an integer. This is not a, in fact you need a natural number because n is the number of sides of a polygon. So this is not a natural number, therefore this exterior angle measure is not possible for a regular polygon. Okay, for a regular polygon it is not possible. So the answer is no, not possible. Right? Next, coming to the next question. So in the next question, we have, can it be an interior angle of a regular polygon? Now they are saying, can 22 degrees be a regular polygon, interior angle of a regular polygon? So if interior angle is 22 degrees, what will my exterior angle be? We have already seen sum is 180. So I will take 180 minus 22, which is nothing but 158 degrees, right? Now exterior angle is 158 degrees. Is it possible? Let us check. N into E is equal to 360 because they are saying it's regular, implies N is equal to 360 by 158. Clearly again this is not a natural number, therefore it is not possible for 22 degrees to be the exterior angle if the interior angle, if the polygon has to be regular. Okay, next question. This is the last question of this exercise. What is the minimum interior angle possible for a regular polygon and why? So now, how do we answer this question? Okay, what do we mean by this? They are asking us what is the minimum interior angle possible for a regular polygon? So if you take any regular polygon, sixth question, if you take any regular polygon, I already know that n into e is equal to 360. Now RHS here is fixed, right? And LHS is product of two variables. One of them belongs to, you know, natural numbers because it's number of sides, and the other is the measure of the exterior angle. Now you will see that minimum interior angle, right? They're saying minimum interior angle, right? Means that we are looking at maximum exterior angle. Why? Because interior plus exterior is always 180 degrees. So whenever we are looking for minimum interior, I have to minimize the interior angle, implies maximize the exterior angle. Now looking at this product here, if I have to maximize this in the product, when the product has to be constant, I have to minimize. If I have to maximize the exterior angle, I have to minimize n, right? And you know that the least number of sides that are required to form a polygon is 3, okay? So minimum n is equal to 3, right? So now that n is equal to 3, E is equal to 360 by 3, which is 120 degrees, and coming to our interior angle, which is what they have asked us, 180 minus 120, which is 60 degrees. So this is the answer for the A bit of the sixth question. Next they are asking us, what is the maximum exterior angle possible? Maximum exterior, like we've discussed, minimum interior angle implies maximum exterior angle, right? So again, maximum exterior angle is nothing but 120 degrees that we have got here. Maximum exterior angle is 120 degrees. Okay. So with this we come to the end of exercise 3.2. Okay. This is about exercise 3.2. In the next video, I am going to start kinds of quadrilaterals, and this is where we are going to start the topic understanding quadrilaterals, right? So that is what we will be discussing in the next video.